location right now, because there are those who are watching us live, there are those who will watch us later on. All in all, we are achieving the same thing. What I'm doing right now is this lesson was supposed to be done during the day, but we had a technical error, and I informed most of those students that we are in the same, we can communicate in other platforms together. I told them that we are going to redo the lesson at 7 p.m. And right now I'm here. We will not stay for so long. I know some are still watching news, some are taking supper, some are doing other things, but thank you for sparing a few minutes to follow our discussion. Our topic is families. What we are checking on here is, when we talk about family, you come from a certain family. I come from a certain family. A certain family will come out of me. A certain family will come out of you. When we talk about family or chemical families, I will use our normal family setup at home to explain this. For example, in a certain family, you will realize that most people in that family are black, very black. Unakutana wao unaona yenyewe au majamaa kama ni rangi iliwatosha vizuri. Na unaenda family nyingine unapata they are very brown. Mshenga si mungekuwa wazungu ama wahindi. Now, in a certain family utapata members of that family are very tall and huge. In a given family, most of the members are very short. So they share a certain characteristic. Na kuna familia ingine watu wako na hasira. I don't know about your family. Kuna familia unachokoza mtu mnapigana naye immediately. Wako na hasira mingi. In all this, they describe a certain family. Now, elements the same. There are those elements which have the same physical properties and chemical properties. They may not be exactly the same, but they look alike. They share most of the properties. They say they belong to one family. Even the way they react, you see, they're the same. For example, the group we are going to study right now is called alkali metals. It's group 1, but the chemical name is alkali metals. Now, it includes lithium, sodium, and potassium. The way they react and behave is almost the same. That's why they're in one group. Another group that we will study probably tomorrow is alkaline earth metals. When we see or check these members, they appear to share most properties, either physical properties or chemical properties. The other day, on Thursday, we will study about what we call halogens, which is another family, including fluorine, chlorine, iodine, and bromine, and others. They share certain physical and chemical properties. They belong to one family. Those who are in, you can check and comment about my audio. If I'm very audible, if I'm audible, you just confirm to me so that we can proceed. Another family is group 8. We call them noble gases. Krypton, xenon, argon. The other day we agreed that it is called argon. They belong to one family. And if it's a matter of physical and chemical properties, they share. Now, we are going to see alkali metal. What are you supposed to know concerning the alkali metals? We are supposed to know concerning what are the members. After the major members, which are for that is lithium, sodium, and potassium. Those are the members of alkali metals. Then we will also check and see some factors that happen in a group. For example, the atomic size, the gradation of the atomic size, the ionic size, all those we are going to see. We are also going to see how they react. We are also going to see their uses. We will check on what is happening with those elements. But before that, I'm trying to check on the comments from some of you so that I can know if there's anything I need to adjust. I'm checking on all the three channels that we are on right now, so that we can proceed. Miki, kila kitu kasawa? Yes, everything is okay. So anyone who has any comment, you place it there. I will. If you have any question, you can still put it there. We will check on that. So let's start by mentioning the members of this group. So members include, I said lithium, sodium. I'm not used to writing the whole name. I think writing of the formula would have done me better. Lithium, sodium, and potassium. These are the main three that you're supposed to know. They are found in group 1. I was explaining something during the day, and I think I have to explain, but that lesson did not end well. We have the name group 1, and this one should be written in Roman numbers. Then we have alkali metal. Alkali metals. Now, let me explain, and so that you understand at what point are we supposed to use the word group 1 and at what time are we supposed to use alkali metals. If you ask, name the group to which sodium belongs, you cannot say alkali metals. That one you will be wrong because they have asked you about group. If you ask, name the chemical family or chemical name to the family to which potassium, sodium, or lithium belongs to, you will talk of alkali metals. Now, group 1 hapa inakuanga na hydrogen. Kuna hydrogen inakuanga hapa, but inakuanga hapo conditionally. This hydrogen stays there conditionally. Why? Because if we talk of alkali metals, it cannot be there because hydrogen is not a metal. But if we talk about group 1, it will be found in group 1. I think I explained in my other lessons that we were doing last week, part 1, about why hydrogen is found in group 1 and also it is found in group 7. Tomorrow or the other day, when we shall be discussing about halogens, you will realize that hydrogen will be a member of group 7. Look at this. Let's look at the electronic arrangement of these elements. Hydrogen, if I write H this way, iko na 1. Lithium, iko na 2, 1. Sodium, iko na 2, 8, 1. Potassium, iko na 2 is to 8 is to 8 is to 1. So these three is here, but these three, these are alkali metals, but all of them are group 1 elements. I don't know whether you are getting me. Now, one characteristics, look at this. If each one of them has 1 in the outermost energy level. 1, 1, 1, 1. Good. Now, what are electronic configuration? They are called electronic configuration. Electronic arrangement. This one has 1 energy level, 2 energy levels, 3 energy levels, and 4 energy levels. Now, down the group, because this is how it arranged itself in that group 1, down the group, this is how it arranged itself. The main question that you always ask is, what is the gradation of the atomic size down the group, or how does the atomic and ionic size changes down the group. Based on the number of energy levels, we can say the atomic size increases down the group. The same applies to ionic size. Now, let me not talk so much about hydrogen. Hydrogen is not a member of alkali metals. Now, lithium ion is having electronic configuration of 2. Sodium ion is having electronic configuration of 2,8. Potassium ion is having an electronic configuration of 2,8,8. So still, when we talk of ionic size, it increases down the group because of the same reason, increase in the number of occupied energy levels. This one, it does the same reasoning, increase in the number of occupied energy levels. So hiyo ni kitu ya kwanza ambayo nimeuliza. During the day, before we end up the lesson I had, I asked a very simple question. Listen here. I know you are ready for it. Compare the atomic size and ionic size of alkali metals. Compare the atomic size and ionic size of alkali metals. In short, I'm asking, you pick one element like sodium, then sodium ion. Between sodium atom and sodium ion, which one is larger? That's my question. I want to see the answer there. Natuharakisha kidogo because of time. Yes. And I want to see people commenting. Faster kidogo. I cannot be in class alone. You have to do what? You have to comment. Beverly, where are you? Munga, I want to see your comment there. Yes, so it's like no one is having the idea of that. Let me explain because of time. Ndio nisikumalizie bundles pia. If you want to answer this question, just write the electronic configuration for sodium, which is 2, 8. It's going to be 2, 8, meaning this one has 3 energy levels, this one has 2 energy levels. So by all means, sodium is having larger size than sodium ion. So the sodium atom is having a larger size than the sodium ion. That is the point. Now, there is another one. It's out of our topic today, but it's good I explain it once. We have chlorine atom and chlorine ion. If I may ask you, which one has... That was where I was during the day before it got disrupted. Now, between chlorine atom and chlorine ion, which one has a higher or a larger size? This one, it was so simple because this one has 2 energy levels. This one has 3 energy levels. So the one with more energy levels automatically is the one that is larger than the other one. Now, so a chlorine atom is 2, 8, 7. Now, chlorine ion is 2, 8, 8. 2, 8, 8. Now, which one is larger? All of them have the same number of energy levels. If you use the reasoning that we have used for alkali metals, you will fail there. You will not give it. My student one day, kumbe alielewa hii ya alkali metals and even the alkaline earth metals. Akapeleka the same concept pale, and she did not score. Now here, one thing that you need to know about this, is that this is going to be larger than this. Why? Chlorine ion is larger than chlorine atom. Listen to the reasoning I want to give. For chlorine atom to form ion, there is gain of electrons. And when electrons are being gained, it means imekuja ikajiongezea what is already existing. Now, there would be a repulsion between the already existing electrons and the electrons that were gained from somewhere else, from another atom. When there is a repulsion between the existing electrons and the electrons that are being gained, then the outermost energy level would move far away from the nucleus, making the ionic size to be larger. Kama umeelewa niambie yes. Tuendelee. Tumeelewana? Good. So now, I would like to explain something else. After size, hiyo tumeelewana na tumemalizia vizuri. Even comparing the atomic and ionic size, hiyo iko sawa kabisa. Now, I want to define a certain term kidogo, but before I define that term, let me define it first. Atomic radius and ionic radius. What is it? Kuna mtu ukimwambia define ionic radius ana define vitu zake. Mwingine ukimwambia define atomic radius ana define vitu zake. So look here. Atomic radius. What will you say if you're told to define atomic radius, and what will you say if you're told to give ionic radius? So the distance between the center of the nucleus and the outermost energy level of an atom is called atomic radius. I will repeat. The distance between the center of the nucleus of an atom to the outermost energy level, that is called atomic radius. But the distance between or from the center of the nucleus to the outermost energy level of an ion is called ionic radius. Yes. Hiyo ni kitu lazima ujue kwanza vizuri. Hiyo concept tumeelewa, right? I hope that's okay. Now, the other thing that I would like you to know, are the physical properties. Physical properties, by the way, let me say this. Whenever you ask about physical properties of elements, of compounds, of gases, of molecules, physical properties include the color, number 2, the texture, number 3, solubility in water, number 4, if it's a gas, the smell, number 5, if it is soluble in water, number 6, the nature, whether it is acidic, basic, or neutral. Such are what you are supposed to give when you ask about physical properties. Now, lithium, sodium, and potassium, all of them are shiny, but lithium is silvery. It is shiny silvery. Even if it is shining, the shining it has is that one of a silvery. Yes, the sodium is shiny gray, and likewise to potassium. Now, these metals, we are used to metals like iron, copper, which are very hard. These ones, they are very soft. You can even cut using your nails, or you can even cut it this way. Using a knife now becomes the easiest. It can be easily cut with a knife. Melting point, this one you have to get it. But I'm not saying you cram, but just know that their melting point is not so high like other metals. The melting point of lithium is 180 degrees Celsius. It melts into liquids. For sodium, it is 98, and for potassium, it is 64 in a term. As you move down the group, the melting point decreases. Likewise to the boiling point. Now, the three elements are good conductors of electricity. Why? If you're told to give a reason, because they have delocalized electrons. Kuna mtu anashangaa what is or what are delocalized electrons? Delocalized electrons. Delocalized electrons. This means free electrons which are used to conduct current. So they are good conductors of electricity. Why? Because they have delocalized electrons. Back up. I want to see kama kuna mtu akona swali. But if it's not there, we will still proceed. Yes. So now, I would like to ask a question. What is ionization energy? What is ionization energy? If you have it, you will drop it on the comment section after like 3 minutes. I would define ionization energy, so you will confirm whether you know or you've typed the correct thing. Ionization energy, before I even come and talk about first, second, and third ionization energy. Are you together? Now, still on alkali metals, I have a question here. My question is, state and explain the trends in the following properties down the group. Appearance. What is the appearance of alkali metals? Number 2. What is the ease of cutting as you move down the groups? You know, we have 3 elements. As you move down the group, we are starting from lithium, sodium, and potassium. All of them, yes, they can easily be cut using a knife. But the ease of cutting varies. Now, as you move down the group, how does the ease of cut varies? That's my question. Yes. I will explain, because I will not expect you to type it. As you move down the group, the ease of cutting increases. That means it is easier to cut potassium than to cut sodium. And it is also easier to cut sodium than to cut lithium. What about melting and boiling points? They decrease down the group because of decrease in what we call bonds. Baadaye tukifika structure and bonding, I will explain that. Now, what about electrical conductivity? How are they? All of them are good conductors of electricity because each one of them has one electron in the outermost energy level. Sodium is 281. Hiyo 1 ya mwisho is the electron used for conducting current. Lithium is 21. Hiyo 1 ya mwisho is the one that is being used to conduct current. Potassium 2881. That one ya mwisho is the one that is used to conduct what? Current. Are you together? Yes. So now, let me move to another question. And the question is, define the term first ionization energy. That one means you must have defined the term ionization energy. I will place it on the comment section, ionization energy. So you will allow me to, so that those who are writing can write it. That comment, I've placed it there. It is called ionization energy. Yes. Those who are writing it, do it very fast. Those who are writing it, let's do it very fast. So in all the three channels, I've given the definition of ionization energy is the minimum energy required to remove an electron from the outermost energy level of an atom in gaseous state. In most cases, students will forget the last word, in gaseous state. And in most cases, when teachers are marking, that's what they are checking, kama umeandika. Kama hujaandika sasa itakuwa shauri yako. Sawa sawa? Yes, so just check on the keywords there, and you will check on it very well. So now, we are moving on. My students from Ambassador Speaks, I would like to hear you speaking and commenting on the same. Likewise to the ones on Mickey Slate Media and the ones on Shifting Grades. Good, I can see a good interaction here. Now, there is this question I ask. All of us, we have seen and we have known what is ionization energy. But my question is, what is fast ionization energy? That's what I want us to start from. Fast ionization energy. I want to put another comment there on how this is explained concerning the first ionization energy, the second, and the third. Now, let me write here. So we have, if it is 2, 8, 2, there is removing of, okay, these are 2 electrons. Now, there is removing of the first electron and the second electron. So, removing of the first electron is easier, but removing of the second electron is harder. So, first ionization energy is the energy required in removing the first electron. Removing the other electron is the second ionization energy. And always, the first is easier. Lakini, kutoa ya pili, because you have removed the electron, the remaining ones are being now held firmly, tightly, and strongly to the nucleus. So it becomes harder to remove it. Good. We're still there. So you now know how to explain electrical conductivity of metals, or specifically alkali metals. Now, I want us to check on what we call, this one I will not spend too much time, because when we were discussing, last week actually we discussed about writing of chemical equations. So anything that involves writing of equations is a chemical property. Sawa is a chemical property. Now, what is there is, so let me just read some comments. Wesley Kims, thank you for commenting. Kitonga, anasema I'm just passing by. Thank you for passing by. Bashir Adan, anasema we also want source form 2. No problem, we shall organize that one. And Shifting Grades, thank you for making that comment. Yes, so we can proceed from there. Yes, so I want to give an assignment. I want you to go and see how these elements, lithium, sodium, and what do we call this? Potassium, reacts with the following. Just write in your own way. Ukishindwa, refer to our lesson of last week, part 1, on writing of chemical formulas and equations, how they react with water, meaning you write equation between water and all this, with oxygen, with acids including HCl, H2SO4, nitric 5 acid. You see how it behaves. And when writing a chemical equations, include observations. When they were reacting, what were you observing in the process of reaction? After the reaction, what did you observe? Very important. Are we together? And also the way they react, very important. So allow me not to end that into details, but it is something that I'm tasking you to be able to do it. Now, ukishindwa, ask that question. Ask in either of our channels. You know, you can ask it in form of a comment, and it will reach all of us. In any of the channels, trust me, it had. Yeah. So we can proceed. I want to ask a question as we are moving on. Yes, that comment, I'm just placing it in the comment section. Then all of us, we tuichangamkia haraka haraka, and you will see it appearing on your screen. Actually, you will see it appearing on the screen there. There is a question nimeweka hapo. You will just see it appearing on the screen. Ndaka tuichangamkia sasa. Yeah, the question reads, what is observed when a hot piece of sodium metal is lowered into a gas jar containing chlorine? We are all seeing that question, right? What is observed when a hot piece of sodium metal is lowered into a gas jar containing chlorine? When we talk about observation, don't tell us about equations, what have you. We want what you can see, actually. Something that you can see. Sawa. So I'm waiting for those who can give us the answer. But I will explain that. Yes, so in swali tu rahisi tu unaulizwa, what is observed when a hot piece of sodium metal is lowered into a gas jar containing chlorine? Of course, it will react to give sodium chloride. That's not what we are asking. We are asking, how does it react? When a hot sodium is lowered into a gas jar containing chlorine gas, it passed into flames. Then later on, white deposits, and these deposits are sodium chloride. They are always white in color. And then a class 3 question, what is formed when sodium and chlorine react? Hiyo tumesema ni sodium chloride. Sawa. The rest you can work on it. Hiyo si kitu ya kukushinda. Now in this case, I want to give the uses of alkali metals. And hii nayo lazima ushike vizuri because it's something that you have to get it. When you are asked to give 2 uses of alkali metals, don't tell us alkali metals is used in. Don't say alkali metals are used. No. Alkali metals are many. Can you mention one? Can you tell us sodium is used in? Can you tell us potassium is used in? Can you tell us this is used in? Hapo tutaelewana. I'm trying to see what kuna swali. Kuna mtu ameuliza swali. Kuna mtu anaitwa Promoter Lil Ouch. You can check on that comment, technician. Amesema thank you so much for the shifting, great for organizing this we are very sawa, no problem about that. Yeah. So Ndaka, if you ask about uses, can you mention the specific one and let it be? For example, I want to give you 2 or 3, then the rest you will do it for yourself. Sodium is used in the manufacture of sodium cyanide, which is also used in the extraction of gold. Now, did you hear me saying alkali metals are used in? No, because there are many. You know, alkali metals is not something, it's a group of elements. So each element has its own use. The uses of potassium are different from those of sodium. So we have to, mention it that way. Now, lithium is used in the manufacture of special high-strength glasses and ceramics. Kuna some glass unakutananga nayo inaanguka ipasuka. Unashangaa hii ni glass inakani. Glass ya kwenu ukiangusha inapasuka. Screen yako ya simu sasa iangushe uone, you can do an experiment, itapasuka tu. Then kuna hii kitu inaitwa sodium chloride. Sisi mnajua. So sodium chloride, which is a compound of sodium, is used in the making of food additive. Sawa? Then a mixture of sodium hydroxide and carbon and carbon disulfide is used in the manufacture of artificial silk called rayon, used in making of clothes. Now, and you can proceed with others. So that is just the introduction part of, or the first part of chemical families, which is the alkali metals. The part that we are going to discuss tomorrow will be the part of alkaline earth metals. I will communicate in the morning whether we will do it at 3 p.m. or at 7 p.m. because during the day kuna shughuli mingi, so we will check on that, maybe 3 p.m. or 7 p.m. Otherwise, kama uko na swali, I'm hanging around for 1 minute to see if there's anyone having a question. I'm checking through the 3 chat channels to see whether there's any question that someone is asking. I'm hanging around for the next 2 or 3 minutes. Okay, be very specific, 2 minutes, so that from my side up to where you are, live streaming has a delay of 1 minute. So I'm hanging around to see if there is anyone having a question. Yes, na wangoje tu nione kama kuna mtu akona swali. Kama hakuna, I wish you a nice supper. Can you name your chemistry teacher? And what's the name of your chemistry teacher? Ama utaki ajulikane? Your chemistry teacher? Yeah, so if you have a question, in the next 1 minute, we are ending the lesson. Yes, thank you. We have so many videos in our channel. You can check on it. The first channel is Ambassador Speaks. The second channel is Shifting Grades, and the third channel is Mickey Slate Media. Yeah, so usiboeke mchana na usiwaste bundle yako kuwatch vitu haikusaidii kwa maisha. Sawa. Yeah, make sure you watch useful things. We have YouTube that enables us to reach where you are, and we are doing it freely of charge. With no question. Oh, kuna kaswali. What is kuna mtu anasema an oxygen atom has a smaller radius than its ionic radius. Explain. At the beginning of this lesson, you can highlight that. I'm going to highlight that. In the beginning of the topic, I explained why chlorine ion is larger than chlorine atom. So even in this case, let me explain this so that we can end it there for today. It says we have oxygen atom inakaanga hivyo, then we have oxygen ion inakaanga hivyo. So oxygen atom has 2:6. Oxygen ion has 2:8. Now this is smaller than this. Yes, why? Because when electrons are gained from outside there to form now the oxygen ion, there is a repulsion between the existing electrons and the electrons that have been gained, and therefore the outermost energy levels moves far away from the nucleus and therefore increasing the distance, making the ionic radius of oxygen ion longer or larger than the ionic radius of oxygen atom. So basically oxygen ion is larger than the oxygen atom. Kuna ingine? If there is no any other, what if we stop there for today? So we are out in 3, 2, 1. Good night.